We are talking about ratios, proportions, and rate of change. We want to compare rates, solve proportions, find percent change, and solve problems involving percent change. So ratio, that's what we're going to start with, is a comparison of two numbers by division. And we have three ways a ratio can be expressed. B cannot be equal to 0 because we cannot divide by 0. So that's why we can't have that there. So we cannot divide by 0, so we can't have 0 in the denominator. And the way that these other ones are written are basically saying divide by B. So we have A divided by B as a fraction. We have A to B with a colon in the middle, and then we have A to B written here. Ratios should be expressed in the simplest form. So if we look here, both of these, if we look at it, we could say both of them are divisible by 6, and we could do it that way, or we could say, well, both these are even. So if they're even, we know we can divide both of them by 2. So 12 divided by 2 will give me 6, and 18 divided by 2 will give me 9. And then we can see that we can further reduce this because we know that they're both divisible by 3. So we can divide 6 by 3, and we can divide 9 by 3, and then we're left with 2 over 3 in the simplest form. We also have proportions, and proportions are two ratios compared by an equal sign. So we're saying A over C is equal to B over D. So we can also say A over C is equal to B over D. So when we write these down, we see that we have C and B. Well, if we're going to write these down in a different version, so we say A to C is equal to B to D. So we can write that down. A to C is equal to B to D. So the means, in this case, we're talking about the middle terms of the proportion. It's kind of hard to see the middle terms as it's written like this, but when it's written like this, we can see that our middle terms are the two terms in the middle. So really, it's C and B. So C and B are the middle terms. And then the next one we have, the extremes, is the first and last terms. So the first and last terms in this are A and D, and it shows up a little bit better when we're comparing A in this way, because then that really clearly shows that they are the first and the last. So the reason that that's important is because we have the properties of proportions, and it's the cross product property. The product of the extremes equals the product of the means. So product, remember that means multiply. And product means multiply. So the product of the extremes, in this case, we have A times D. So I can write down AD is equal to BC. So we have the means times the extremes. Well, we can work at that in a problem as well. Here we have our extremes. With our extremes, we have 1 times 9, and that is going to be equal to 3 times 3. So basically we end up with 9 equals 9. We have another example where we want to try to figure out what the solution might be. We already have it written here because we have 1/3, 1/3, 9 in the denominator. We already know what the answer is, but this is how we could solve to figure out what it is. So we have our extremes, which is 1 times 9, and that is equal to the means, which is 3x. So how do we get x by itself? Well, 1 times 9 is 9, and that is equal to 3x. So what operation do we have on the right? Yeah, we're going to use GEMDAs because we're solving right now. We don't have addition and subtraction, but we do have multiplication. So we will divide. And then what we get is x is equal to 3. And that's what we had before when we started, but this is how we can use cross multiplication to find a missing term in the product, or excuse me, in the proportion.